Okay, so we're taking notes on 3.6. Our objective, or OBJ, is slope and parallel and perpendicular lines. Our EQ today is the relationship between two lines can be determined by comparing their slopes and y-intercepts. I'm going to move this up. And you're writing down your cues. Remember, we're going to do our cues later on. Don't worry about your cues right now. We'll do that when we do our summary days, when we do our questions and summaries. And then on our notes today, we have 5 bullet points. We may not get through all 5. We'll get through 4, but maybe not all 5, but you guys will be able to do this. The first sample that you see there is on parallel. I know I'm going fast, but we have a lot to do, so get it written down as quickly as possible. Okay, on this first thing, by the way, this is not a bullet point, okay? These are examples that I need for you to write down. I'm making the assumption that you have, rather you know the symbol for parallel and for perpendicular. Did you guys have this last year with Mr. Reese? Okay, do you recall this symbol right here, parallel? 2 lines, 2 straight lines look like the number 11, but thicker and taller. How about this one right here, perpendicular? You guys remember this one, this symbol? No? Oh, okay. All right, so we need to cover it today, and I will definitely do that. Okay, spend some time doing it. Okay, so if the slopes are parallel, they will have the same, excuse me, I'm sorry. If the lines are parallel, they will have the same exact slope. 1/2, 1/2. The M, the montaña, the mountain, the rate of change, the rise over run. They will be exactly the same if they are parallel. If they are perpendicular, then there's 2 criteria that it will meet. And I will write this up on the board in just a moment. So let me slide this up just a little bit. If they are perpendicular, then we're going to have 2 different criteria that have to be met. If they're perpendicular, this is positive, this one's negative, so we say they are opposites. One more time. This one's positive, this one's negative. And then over here on the slope, we say that this is the reciprocal. The reciprocal. So they have to be both the opposite and the reciprocal, or multiplicative inverse, same thing, reciprocal of each other. Must have 2 criteria in order to be perpendicular. In order to be perpendicular. I'm going to give you about another 15 to 20 seconds, and then we're going to go ahead and move on. All right, ladies and gentlemen, this is going to sound a little strange, but I want you to think about parallel and perpendicular and where you encounter it or where you see it. So in your notes, right below the last thing that you wrote right here, in your notes, I want you to write this down. Parallel or perpendicular? Where do you encounter this or see this in your daily life? I only want you to write a list of 5 things that you encounter. Don't tell me, write your own list. Write your own list, don't say anything. Write your own list right now of where you might encounter either parallel lines or perpendicular lines. I only want you to make 5. You might come up with 10 or 20 or 30, but I just want you to come up with just 5. 5 things that you encounter either on a daily basis or a weekly basis, maybe a monthly basis, where you see either parallel lines or perpendicular lines in your life. Okay? Where in your life would you see them? Okay? Parallel and perpendicular lines, where might you encounter them? Okay? What kinds of things would you, where would you encounter it? Think about it. Okay, someone raise their hand and tell me where you might encounter parallel and perpendicular lines. Ruben.
McDonald's lines.
The McDonald's lines like this right here? Like that? Yes? Oh, you mean the lines on the ground or yes? Okay, so McDonald's drive-through, I'm just going to put down any drive-through.
The drive-through is the middle, not the window, you order.
Oh, okay, where you order. Okay, yes, okay, got it. Where else, Jose?
Railroad?
Railroad! Yes, the railroad tracks, that was pretty good. Okay?
Regular roads?
Regular roads, just roads in particular, aren't they all, parallel and perpendicular lines, the 2 lines? Okay? Where else, people? Paper, that's exactly what I was thinking of, the first thing. Paper. Look at this piece of paper that's on your desk right now. You see the parallel lines? Do you also see the perpendicular lines? Perpendicular lines. They're both parallel and perpendicular. Where else? Someone else give me one. Someone else other than Ruben. Okay. How about Kate? Give me one on your list. Ruler. Exactly. Okay. Look at this. Parallel lines. They're also perpendicular. Okay, now I want everyone to stop what you're doing. Look up to the ceiling. Do you see any parallel or perpendicular lines? Yes. Look at these parallel lines. This is a false ceiling or drop ceiling. And the metal brackets that you see right there hold in the tiles. Okay, that's framing is what it is. It holds in the tiles. And you see nothing but parallel lines. You also see parallel lines going this way. And then when you look at them, they make a 90-degree angle or perpendicular lines. You see them all around the room. Look at the table. Parallel lines. You see it in the ruler. You see it in the desk. You see it up here on the screen. You see it right back there at the doorway, the door jamb right there. Parallel lines. Look at the window. Parallel lines. Look at the shelving units over here. Parallel lines going vertical, going horizontal. They're all over, everywhere. Think about your house. The pictures on the picture frames on the wall. So, yes, your skimmers that you're doing in period 1, if you have them in period 1. Okay, so parallel lines are all around us, and they're used to manufacture and make things because it's simple and cheap. Okay, inexpensive. So you will encounter them. So that's a good reason to know this information. So we're going to start off with our first bullet point of the day. Everyone is going to write this down. Writing an equation of a parallel.
In this problem, you will write an equation of a line parallel to a given line. A line passes through the point, 12, 5, and is parallel to the graph of y equals 2/3 times x minus 1. What equation represents the line in slope-intercept form?
Okay, we're going to need 2 pieces of information here, aren't we? We're going to be needing to write down this, which is the point that they're asking us about. And we also need this, the equation, y is equal to 2/3 x minus 1. Now, before we go any further, we should remind ourselves that this is in slope-intercept form. Y is equal to mx plus b. Okay? Y is equal to mx plus b, because that's what they want. So now, they want us to calculate and figure out what would this line be like. Before we go any further, let's review from last year quickly what this would look like. If I have something that is parallel, then this is what I'm saying. On a graph, if I have a line going like this line right here is exactly the same. So that means this line has a slope of, let's say, 3. This line has a slope of 3. Both slopes are the same, so they are parallel. Now let's go to perpendicular. I have a graph like this, and I have one line going up and another line crossing at a 90-degree angle. What criteria must be met for the slopes? This line might be 3, but this line has to be both opposite and reciprocal. Negative, that's positive, that's negative. Opposite and reciprocal. What's reciprocal? 3. 3 over 1, the reciprocal is 1/3. So if this is 3 over 1, 1/3. Reciprocal or multiplicative inverse. So remember, this one's positive, this one's negative. This one's 3 over 1, this is 1 over 3. What about this, ladies and gents? There's parallel, perpendicular. What about this one? What if I gave you a line that was like this? Okay? Slope of 3, slope of -2. Is it parallel, perpendicular, or neither? Neither. It's none of those. So now, keeping this in mind, when we're approaching this problem, we're going to have to solve this right here. So we're going to go back to what we've done so far. First thing we're going to do is put down x sub 1, y sub 1. We're going to start right here. Now, knowing this, we should be able to throw it into an equation. We learned an equation last week. What was that equation called? Does anyone remember? Point slope form. Good, Edgar. How do we write it? Y, yeah, Edgar. Good. Fantastic. Y minus y sub 1 equals m times the quantity x minus x sub 1. So I think we're going to go ahead and use that one to solve this problem. So let's go ahead and make an attempt. Yes, we're going to go ahead and do that. So we started here by writing down the formula. Now we're going to substitute. Substitute. So y sub 1, put in here. X sub 1 to put in here. And go ahead and write it out and see what you come up with. So Emmanuel, what do I write? Tell me what to write down. Y minus equals 2/3 times the quantity x minus do what? What's the value of 12, right? I mean, the value of x? Okay, my bad. Okay, now that we have this, people, this is all fine and dandy, but it says, no, we want it in slope-intercept form. They want it in this form. So we have to do something. Distribute. Distribute. So go ahead and distribute this. Let's see, writing. What is 2/3 times x?
2/3 x.
And what is 2/3 times -12? Uh-oh. We're going to have to do some work here. 2/3 and then a 12 over 1. Is there a simple way of doing this? Could we do this? How many times does 3 go into 12?
4.
And 3 goes into 3 once? So 2 times 4 is? 8. 8. And then 1 times 1 is 1. 8 divided by 1, Riley, is? 8. So we get minus 8. Okay, we get this, but it still doesn't look right to me. Something's wrong. Wait, it doesn't look like this. So what do we have to do, Hugo? Add 5 to both sides. Add 5 to both sides. Christian, what is 5 minus 5?
5, 0.
0, good. We get y is equal to 2/3 x. And Christian, what is negative 8 plus 5?
-3.
Negative 3. Now, ladies and gentlemen, we're going to do a comparison here. Okay, in your notes, you're going to write these two side by side or underneath each other or next to each other. I'm going to write it right up here. All I'm going to do is just take this and write it over here. Y is equal to 2/3 x minus 3. You're going to focus in on the M, the montaña, the mountain, the rise over the run. Okay, the rate of change. Are these two slopes the same? Yes or no? Yes. Uh-oh, I heard someone say no. Is 2/3 equal to 2/3? Yes. So the slopes are exactly the same. The montaña, the mountain, are the same. Because they're the same, then that means they are what? Are they parallel, perpendicular, or neither?
Parallel.
They're parallel. So these two are parallel. So write that in your notes. Okay? So far so good. You're batting 1,000. All right? Piece of cake. Easy squeezy lemon squeezy, right? Okay. I'm fine. Yeah, I'm fine with it. Yeah. Okay. All right. So we now know that they are parallel. Piece of cake, right? Easy. Now let's kick it up a notch. Here we go. Second bullet point. Second bullet point. Here we go. Second bullet point. Classifying lines. Classifying lines.
In this problem, you will classify lines. Are the graphs of the equations 4 times y equals -5 times x plus 12, and y equals 4/5 times x minus 8 parallel, perpendicular, or neither? Explain.
Okay, so before we even start this, people, I want to review what we just talked about. This over here, I said, were parallel lines. When the slopes are exactly the same, they are parallel. When they are perpendicular, that means they make 90-degree angles like you see all over the ceiling here, 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, that means this is happening. We have our x and our y-axis on a coordinate plane. We have one line coming up like this, maybe perhaps another line as an example. Well, that wasn't very good. Like this right here. They make a right angle, so 90 degrees, but wait a minute, what's more important? This slope is positive, so I'm going to put a +3 right here. Positive and a number. This slope is a negative and the reciprocal of this. Remember that this is 3/1. So, Emmanuel, what would this be?
1/3.
1/3. So now we have perpendicular lines, so there's parallel, perpendicular, and then we have that other option called neither. Neither. So, we're coming over here like this, and we're saying, oh, how can we make a neither so that it's not like this or like this? So, one could be positive, one could be negative, but what if it was just like this? So if we had a slope of, let's say 3, and this was -2. They're neither. They're not this nor this. Okay? They're similar and close to this, but not quite. So, neither. So this is what we're trying to do. So here we go, people. So, we're writing these two down. 4y is equal to negative 5x plus 12. Oops. And y is equal to 4/5 x minus 8. We have to determine whether they are parallel, perpendicular, or neither. These are our three choices. Okay, so we gotta change this. At city, how do I change this right here? What do we gotta do? Make our left right teeth, good, yes, that's fantastic, that's a good start. Now what do I do at city?
You divide 4
Div-
on the side.
Divide by 4 to everything in the equation, that's right. And we get y is equal to what at city?
Negative 5 over 4x plus 3.
Fantastic. Okay, so now, ladies and gents, if it makes it easier, slide this one over here underneath this one. So I'm gonna put an arrow like this, and I'm gonna write it like this. All I did is copy. And the thing I'm gonna look at is this right here. The mountain, the montaña, the rate of change, the slope, the rise over the run. It's all the same thing. I'm looking at this right here. This is our key. I'm seeing which one of these three does that apply to. Does it apply to the parallel lines, perpendicular lines, or the neither lines? So that we're gonna vote right now. We're gonna let you process, think. And now, we're gonna take a vote. How many people think it's parallel? Raise your hand. How many think it's perpendicular? Raise your hand. How many think it's neither? Raise your hand. Well, you were absolutely correct. It's perpendicular. We have a positive and a negative. 4 over 5. The reciprocal or multiplicative inverse is 5 over 4. Yes, it's perpendicular. Right now, using the markers in your pencil boxes, I want you to do the next one on the table. The next one on the table, I'm gonna go around and look at your work right now. Here we go. Okay, so the next one, everyone is gonna do by themselves, and then I'm gonna have you get help or ask for help from the people at your table, okay? Ruben,
Yeah.
you have to go to the attendance office.
Oh, no.
Sorry, back. Okay,
I don't know what B1 is.
D1,
B1.
No.
this is B1.
It's the one.
Oh!
You're going to the office.
My bad.
Just joking around. That's how Ruben is. Okay. All right, ladies and gents, I want you to calculate this, solve it. Is it parallel, perpendicular, or neither? And then once you get an answer, talk to your table mates and find out what they have, and then see if you agree or disagree and why.